Assalamualaikum. My name is Nur Hanani.
My name is Muhammad Nasri bin Shawwal.
Okay, today we will present about automotive component manufacturing for assignment 2. Okay, the component that we choose is piston.
Okay, one is a piston. A piston is a moving disc enclosed in a cylinder which is made gas tight by piston ring. The disc move inside the cylinder as a liquid gas inside the cylinder expand and contract. A piston is in the transformation of heat energy into mechanical work and vice versa. Because of this, pistons are a key component of heat engine. Piston work by transferring the force output of an expanding gas in the cylinder to a crankshaft, which provide rotational momentum to a flywheel. Such as a system is known as a reciprocating engine.
This is the part of piston which is consists of head and connecting rod. Okay, this one is head piston consists of 5 things. First is the crown, the top surface closest to the cylinder head of the piston, which is subjected to tremendous force and heat during normal engine operation. Second one is the ring length, the relief cut into the side profile of the piston, where the piston ring sits. Third one is oil control ring, or we call it as oil ring groove. Recesses are relocated around the perimeter of the piston that is used to retain a piston ring. Then piston skirt, the portion of the piston closest to the crankshaft that helps align the piston as it moves in the cylinder bore. The last one is wrist pin boss, a board that connects the small end of the connecting rod to the piston by a wrist pin. Connecting rod is the rod that carries the force from the piston to the crankshaft. It is constantly subjected to stretching, scorching, and bending force as it acts the intermediary in this push-pull relationship. The connecting rods need to be structurally strong, and it's no coincidence that it takes the form of a miniature steel I-beam, similar to its bigger brother holding up skyscrapers and bridges. The I-beam profile gives a maximum of structural strength at the minimum weight cost, and like the piston, we want to keep the weight of the connecting rod as low as possible. The top of the connecting rod that is secured to the piston is called the small end. It won't always having bearings. The bottom part of the rod is called the rod cap, and it will be secured by either studs or bolts to the rod itself. The big end will have bearing inserts in two halves. This bearing insert will be made of the same material. Wrist pin, the piston is attached to the connecting rod through a hollow, hardened steel tube known as the wrist pin or gauge pin. This pin passes through the small end of the connecting rod and allows it to pivot to the piston. There are two methods of securing the wrist pin. A semi-floating arrangement has the pin fits into the connecting rod, while free to rotate in the holes in the piston. A fully floating wrist pin will be free to rotate in the both small end and the piston, and it will be secured in place using clips of Teflon buttons in the end of the pin. The wrist pin may be slightly offset laterally rather than exactly centered on the piston. This is known as an offset wrist pin and is used to cut down on side-to-side movement of the piston within the cylinder. The material used for manufacturing for piston, the material and design contribute to the overall durability and performance of an engine. Most pistons are made from the cast aluminum alloy. Cast aluminum alloy is lightweight and has good structural integrity and low manufacturing cost. The light weight of aluminum reduces the overall mass and force necessary to initiate and maintain acceleration of the piston. Piston rings are generally manufactured from cast iron or stainless steel. Okay, for piston manufacturing process, it consists of First is manufacturing by casting, an object made by pouring molten metal or other material into mold. First one is foundry. The beginning of the piston, ingots of aluminium are heated in a furnace. The molten aluminium is poured in a hydraulic mold. The material is then scooped up with a ladle from the crucible, the pot that holds the molten material. The material is then allowed to cool. Second one is the hardening and machining. The fresh obtained pistons are dehorned first by a vertical milling machine. Dehorned pistons are hardened in an oven prior to machining. And in a lathe machine, the rough edge are cut and smooth profile is obtained by means of a turning operation. For CNC lathe, at the first cut of the piston is finished. After the CNC is programmed to cut the ring groove, second one is make a accurate bore diameter and finish the crown. Fourth is 5-axis CNC machining. In this machine, the oil slots and pin bore is made. For grinding, the process involves the final size beam machine of the piston. The grinder machines the skirt of the piston only, and in the majority of cases is cam ground. Cam grinding ensures the piston will grow evenly in the bore of the engine. For the final expansion, at this stage the piston is cleaned, fitted with the appropriate grease pins, stamped with the piston oversize and any other markings, and then sent to the specs. For fogging, is the operation where the metal is heated and then a force is applied to manipulate the metal in such way that the required final shape is obtained. For the first one is the rod. The piston begins as a 3-meter solid aluminum rod. The reason aluminum is used is it is lightweight, rust-proof, and easy to cut. A saw then cuts the rod into smaller pieces called slab. Second one is the punch. A punch press and die are preheated while the slab moves through an oven, heating it to 426 degrees Celsius at the punch press. The slab is then removed from the oven and placed into the punch. The press applies 2,000 tons of pressure onto the slab, forging it into the basic shape of a piston. This process causes the piston to become so hot that it needs an hour to cool. Third one is the oven. After the fogging cool down, they go through an oven twice more. The first time is a higher temperature to strengthen the metal. The second time is a lower temperature to stabilize it. The wristband hole and oil control hole. A large hole is then drilled through both sides of the piston. This is where the wrist pin will go, attaching the piston to the connecting rod. Oil control holes are drilled. Ring grooves, 3 ring grooves are created by a lathe machine. For the milling machine, a milling machine then shifts up to a couple of centimeters of each side of the piston, where the large hole will drill for the wrist pin insertion. This is to reduce the overall weight of the piston. For the grinding, the next step involves grinding of the piston for its heat to the crown the shape required according to the design. A lubricant is used to cool the workpiece continuously. Okay, so to finishing the job, another lead shift a few more millimeters of the top, allowing the piston to expand when heat builds up inside of it. Then a machine engrave model and production information. Finally, the piston sprayed by hot the ionized water, removing any lubricant or oils added through the manufacturing process. After they are dry, so ready for use.
Okay, this is a simulation of assembly piston static test of pressure. Okay, this is a result of a static test. Okay, this is SolidWorks simulation. Firstly, for run this test, you to select the material of piston pin piston rod cap, piston rod, and piston head. Then after select the material, select the connection. The connection we select is there of a piston head and connecting rod. Okay. After that, after select the connection, fix the geometry. This fix geometry of piston, and then insert the external load. Okay, for this test, we use external load about 120 psi. Then after select the internal load, you create the mesh of a piston. Then after that, run the study, and then you can get a result of stress, displacement, and strain. Then after that, to finish this test, you can generate the report, and then you can get more detail about the static test about pressure. Okay. Next, this is a compare about the static test of simulation pressure. Okay, first, this comparison of strain, stress, and displacement about static pressure. You can compare the result of three type of tests. Then simulation of assembly piston static force. This is a force test. Okay, in SolidWorks, this is a force test. Force test same like pressure test. You select the material, then select the connection, fix the geometry, and insert the load, and create a mesh. After that, you run the study, and you can get a result about the force test. Then you generate the report to get more detail about the force test. Okay, this is a compare result of static test of simulation, same like the pressure test. This test show the strain, displacement, and stress about the force test. Okay, lastly, simulation of assembly piston thermal test. For this test, we use a thermal test for piston to see the temperature of piston. Okay, this is a thermal test of piston. Okay, similar static. You select the material, and then select the connection. This this is a connection of piston connecting and heat piston. Then insert the thermal load. For this test, we use 500 degrees Celsius of temperature of the low of the temperature about the test, and then you create the mesh and run this study. After that, you can generate the report and see the detail about the test. Okay, that's all for me. Thank you.
Okay, thank you.